Hello and welcome to all. Today is our practice session for exponents, and today is going to be a massive review of exponents. We're going to cover everything from evaluating variable expressions to evaluating powers and volume, which we just talked about in the previous video. So let's get started. So our first question is we're asked to evaluate these variable expressions when b is equal to 4. So how are we going to do this? Well, we're just going to substitute 4 every time we see b. Okay, so let's start with the first one. We have b squared. So I'm going to write 4 squared. Now we're going to write out our factors, and this will be 16. Okay, now if you already knew that 4 squared was 16, you can just go ahead and skip this part. So you could just write 4 squared and then 16. That's totally fine. I write out this step right here so that we really understand what this exponent is asking us to do on this base, okay, and so that everyone is here with us. Now for the next variable expression, we have 1 plus b raised to the cubed power. So again, we're going to substitute 4 every time we see b, and this will be 1 plus 4 times 4 times 4, or 1 plus 64, and 1 plus 64 will give us 65. Okay, hopefully that is making sense and is a good review for you. Let's go ahead and move on to the next slide. Now we are going to review the power of grouping symbols. I know how important they are, and I know how important they are to you as in terms of your success as a student, so we're really going to drive that point home. We're asked to evaluate this variable expression when b is equal to 4. For this one on the left, this variable expression on the left, and this variable expression on the right. So let's get started. So b is equal to 4. So every time I see a b, I'm going to replace it with a 4. I have 4 times 4 squared. I'm going to evaluate this power first. And 4 times 4 is 16. And 16 times 4 is going to give me 64. Okay, again, we're going to learn different techniques on how to evaluate exponents in later chapters, but for now, this is our technique. Now for the next problem, we are given 4b, and this quantity is squared, so we have a grouping symbol here. Again, we're going to replace 4 every time we see b. So we have 4, actually I'm going to use the bracket again. So 4 times 4, all of this squared. So 4 times 4 is going to be 16. 16 squared is going to give us 256. Okay, so this example, the goal of this example was to show you how important grouping symbols are when we are evaluating expressions and how they help us direct our attention throughout the problem. Okay. So go ahead and jot that down so that we can move on to the next slide, because we have a lot of work to do, which is really exciting. Okay, so we're going to write the following expressions in exponential form. So we have 2 cubed. So we're going to basically translate these words into math. Okay, so 2 is going to be my base. So I'm going to write 2. And cubed, we said, was 3. So cubed is going to be my, well, 3 is going to be my exponent. So I'm going to write 3, 2 cubed. Going on to the next one, we have p squared. P is going to be my base. And squared means 2, so 2 will be my exponent. Okay. Going on to the third one, 9 to the 5th power. I know 9 is going to be my base. And to the 5th power is telling me that I need to put a 5 as my exponent. Okay. So for the last one, we have b to the 10th power. So b is my base, and 10 is going to be my exponent, b to the 10th, okay? All right, let's go ahead and move to the next example. Here we have 3. So for the first one, we have 3 times 3 times 3 times 3, and we want to show that in exponential form. So I'm going to write, so my base is 3, the big number. And if you want to imagine, I have ones here. 1, 2, 3, 4. You can count the ones, or you can count the amount of times that we multiply 3. So it'd be 1, 2, 3, 4. So it'd be 3 to the 4th. For the second one, we have 4y times 4y times 4y. And here, our base would be 4y. And our exponent would be 1, 2, 3. So you could write 4y, and we want to use our grouping symbols because we want this to be clear that our base is 4 times y, okay? 4 times y, all of this raised to the 3rd power, because this does not mean this, no. This means 4 times y, and the y is being cubed. I encourage you, actually, I challenge you to actually see this. 4y cubed is not equal to 4y cubed. Just plug in anything greater than 1. So if you multiply 2, for example, it's going to be different. So plug in y is equal to 2 to this, and you'll see, because this is what we just talked about grouping symbols and their importance, and this couldn't be a better example of how to express that, okay? So enough about that. We are going to actually move on to the next one. Got a little sidetracked. Okay, for this one, we have 2x times 2x times 2x. So our base is 2x, and all of this is being multiplied 3 times. So 1, 2, 3. Okay, so let's go ahead and jot all of this down so we can move on to our next example. So now we're going to evaluate powers. Now we have this power in exponential form, and we want to find the result. So for the first one, we're going to write 9 times 9, because 9 is being acted on 2 times by this exponent. So we have 2 factors of 9. So 9 times 9 will give us 81. Okay, and this would be our answer. So we smile because we're happy. Okay, and now for the second one, we have 2 to the 4th. So I write 4 factors of 2, and I multiply this out. So 2 times 2 is 4, times 2 is 8, times 2 is 16. Okay. Now for the last one, we have 3 cubed. So I'm going to write 3 factors of 3. And I multiply this out. So 3 times 3 is 9, times 3 is 27. Fun. Okay, exciting. Now we're going to move on to the next slide. So go ahead and jot all this down. So again, we're going to evaluate more powers. So here our base is 2 and our exponent is 6. So we're going to write 6 factors of 2. 1, 2, 3, 4, 5, 6. So this is actually going to be 2 to the 6th power. (64). 2 times 2 is 4. 2 times 2 is 4. So this will be 16. 16 times 4 will be 64. 5 cubed, we're going to write out 3 factors of 5. So it'll be 5 times 5 times 5. So 25 times 5 will actually give us 125. We have 1, to our last one, we have 1 to the 8th power. So we would write 8 factors of 1. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. Yeah, so 1 times 1 times 1 times 1 is just 1. Okay, so let's jot all of this down and continue on to the next slide. Okay, now we're being asked to evaluate the expression for the given value of a variable. For the first one, we are told that w squared, we're given w squared when w is equal to 12. So we're going to substitute 12 every time we see a w, so we'll have 12 squared. Now to evaluate this, I'm going to write out the factors, 12 times 12, and that will be 144. For the next one, we have b cubed, and we're told to evaluate when b is equal to 9. So we have, so we would write 9 cubed, and we would write out the factors of 9 3 times. So 81 times 9 would give us 729. Okay. So let's go ahead and move on to the next example. We're asked to evaluate c to the 4th power when c is equal to 3. So wherever I see a 3, I am actually going to write a 3. So 3 to the 4th is going to give us 3 times 3 times 3 times 3, which will be 81. Okay, and you could just, you would just multiply 3 times 3 is 9, times 3 is 27, times 3 is 81. Or you can just do 3 times 3 is 9, 3 times 3 is 9, and 9 times 9 is 81. Okay? So for the next example, we have 9 squared, and we're asked to evaluate when 9 is equal to 11. So wherever I see a 9, I'm going to put 11. I'm going to square this, so 11 times 11, and that should give me 121. Okay, so let's go ahead and jot all of this down so that we can move on to the next example. So again, we're going to evaluate these powers, but the first one, we're asked to evaluate 10 squared. So I'm going to actually write 2 factors of 10 because my exponent is 2. So 10 times 10, that will be 100. Okay. Now for the second example, we have 0 raised to the 6th power. So I'm going to write 6 factors of 0 because my exponent is 6. 3, 4, 5, 6. And what is 0 times 0 times 0? It's 0. 0 is such a fun number, like 1, e, pi. You'll learn to like 0. 0 is a cool guy or person or being. Okay, enough about that. Alrighty then. So let's go ahead and move on to the next example. And now we're going to evaluate variable expressions when we have 2 given variables, okay, 2 given values for a variable. So what we're going to do is substitute and simplify. This goes back all the way to our first section of plugging and chugging, substituting in our value and carrying out the operation. So C we're told is 4, D we're told is 3, and all of this quantity is going to be squared. So now we have grouping symbols. So we're going to do the operation, the addition inside of the parentheses first, and then we will evaluate this power. Okay, so I'm going to add 4 plus 3 is 7. And now 7 squared would be 7 times 7. What's 7 times 7? 49. Okay, and that would be our result for this variable expression evaluated when c is equal to 4 and d is equal to 3. Moving on to our next one, we are told that we have d squared plus c. Okay, so we're going to substitute. D is 3. We're told it's 3, so d squared, just write it out like this, plus, and c is 4. So I'm going to evaluate this power first. So I'm going to have 3 times 3. So plus 4. So 3 times 3 is 9. And plus 4 will give us 13. Okay, so that's our answer for this one. So let's go ahead and go on to the next example. We're asked to evaluate the variable expression again when c is equal to 4 and d is equal to 3 for the following variable expression. So let's get started. We're told that c is equal to 4, so we're going to plug that in, 4 cubed, and then d is 3, so I'm going to write 3. 4 cubed, we can just write 4 times 4, bring down the 3. 4 times 4 is 16. 16 times 4 will be 64, plus 3, this will give us 67. Okay, moving on to the next example, we have d squared minus c squared. So we're going to substitute our values. So we're told that d is 3, so you write 3 squared minus, we're told c is 4, so it'll be 4 squared. 3 squared, we're going to evaluate that power, so 3 times 3 minus 4 squared, so we would write 2 factors of 4. 3 times 3 is 9, minus 4 times 4, 4 times 4 is 16, and this would be negative 7. Okay, now how did I get this? I used the keep, add, opposite. So I kept my 9 the same. I didn't change the sign. Instead of subtracting, I added, and I made the 16 into its opposite. So negative 16. So 9 plus negative 16 is going to give me negative 7. Okay. If you have any questions about this, I would be happy to answer. Okay. So we're going to move on to our next example, and we're asked to evaluate the expression for the given variable. So for the first example, we have 2x squared, and we're asked to evaluate when x is equal to 7. So again, we're going to substitute 7 whenever we see an x, so it'll be 7 squared. I'm going to evaluate this power first, so 2 times 7 times 7, and this will actually be 49 times 2. So 2 times 49. So 2 times 49 will be 98. Okay. Now for our next example, we have 6t, and t is raised to the 4th power, and we're asked to evaluate when t is equal to 1. So I'm going to write 6 times 1, and the 1 will be raised to the 4th power. So just for clarity's sake, I'm going to write out the 4 factors of 1. And we all know that 1 times 1 is 1, times 1 is 1, and 1 times 1 is 1. So this is just 1. So 6 times 1 is 6. Okay. So let's go ahead and move on to the next example. And we're asked to evaluate the expression for the given variable. So we have 7b squared, and we're asked to evaluate when b is equal to 3. So I'm going to substitute 3 for b and squared. Now I'm going to evaluate this. I'd write 3 times 3. So it'd be 3 times 3 is 9. And this would be 63. Okay, so you don't need to write all of this out, all of these factors out if you already know from memory, if you've already committed to memory this, or maybe, this 2 squared is equal to 4. These kinds of things, I do encourage you to memorize, and they'll be very helpful. But if you always need some sort of clarification, you can always write out the factors for that. Okay. So we're going to move on to our next example. We have 5w, 5 times w, and this product is being raised to the second power, and we're asked to evaluate this when w is equal to 2. So I'm going to replace 2 wherever I see a w. All of this is going to be squared. So 5 times 2 will give us 10. And now we squared the 2. So I write out my 2 factors of 2. So 10 times 10 will give me 100. Okay. Alrighty then. So let's move on. Again, we're asked to evaluate for this variable expressions when we're given a variable. So we will replace 1 for x in this example. So 4 times 1, all of this raised to the third power. So 4 times 1 will give us 4. And this 4 raised to the third power, we write out 4 times 4 times 4, and this will give us 64. Okay. And now for the next example, we have the same thing, 5y, and this product is cubed, and we're asked to evaluate when y is equal to 2. So I'm going to write 5 times 2, and I'm going to cube this entire quantity. So 5 times 2 is 10, and then 10 cubed will be 10 times 10 times 10, and this will be 1,000. Fun. I'm having fun. Are you having fun? Okay. Hopefully you are. Okay. Now for this example, we are asked to evaluate the expression 2x squared when x is equal to 5. So I'm going to substitute 2 times 5 squared. Okay. Now I'm going to evaluate the power. So 5 times 5. Oof. Sorry. So 5 times 5. Much better. 5 times 5 is, what is 5 times 5? It's 25. And 2 times 25 will give us 50. Okay. We are going to move on to our next example, which is a volume problem. Okay. Yes, this is exciting. Elena is moving to college and she bought a trunk to store her clothes. What is the volume of the trunk? So our approach today is we are going to write our volume equation for a cube. Then we're going to substitute and evaluate. Okay, so the volume of a cube is going to equal side cubed, s cubed. So what is s? S, we're told from the figure. So this is why it's important to always look at the figure as well as the word problem. The figure tells us that the sides are 2 feet in length. So we write 2 feet. Okay, now for step 2, we're going to substitute 2 feet for s. So we would write volume is equal to 2 feet cubed. Okay, now I'm going to write out my factors of 2. So 1, 2, 3. And out here, I'm going to write feet cubed. So now I'm going to carry out this multiplication, and inside of the parentheses, 2 times 2 is 4, times 2 is 8. and I bring down my units, so feet cubed. So this is the volume that Elena's trunk occupies. This is the amount of space that this trunk occupies in 3 dimensions, okay? So let's go ahead and jot all of this down so we can move on to our next example. So we're asked to evaluate the expressions for the given value of the variable, and this is a bit of review from, this is a bit of review from our 1.1 section. We're now in 1.2. This is for algebra and variables, where we introduced our concept of variables, variable expressions, and we learned about substitution. So let's go ahead and review a bit of this, but because we're already doing exponents, I'm sure you're already an expert in this, but it's always a good thing to go back and refresh your memory on the foundational concepts, especially in the previous section. So we're told that a times a, this is our variable expression, and we're given that a is equal to 4. So we're asked to evaluate this. So we're going to write 8 times, so a is equal to 4, so I'm going to write 4 here. Now we multiply this, so 32. So for the variable expression a times a, when a is equal to 4, the result is 32. Going on to the next one, we're given 9 times t, and we're asked to evaluate when t is equal to 7. So I'm going to write the same thing, 9 times, but instead of a t, I'm going to write 7. 9 times 7 is going to give us 63. So for the variable expression 9 times t, when t is equal to 7, our result is 63. Okay, so let's go ahead and continue. Again, we're asked to evaluate this. C plus 15 when C is equal to 12. So I'm going to write 12 plus 15. 12 plus 15 is 27. For the one on the bottom, we have 35 minus y. So this one is I'm actually going to let you try this one out, and then we will come back and talk about our answer. Okay, hopefully you got a good crack at this. Now let's go ahead and talk about what our approach is. So we have 35 minus y. This is our variable expression, and we're told that y is equal to 14. So we're going to evaluate this. I'm going to substitute 14 every time I see a y, so 14. Now I carry out this multiplication, and this will be 21. Fairly simple, right? But so important. Okay. Now we are asked to evaluate these variable expressions that have division or a quotient. So we have 24 divided by x, and we're asked to evaluate when x is equal to 3. So we're going to replace 3 every time we see an x, so we'll be here at the bottom. What is 24 divided by 3? That would be 8. Okay. And for the one on the bottom, we have x divided by 2, and we're asked to evaluate this variable expression when x is equal to 16. So wherever we see an x, we're going to replace it with a 16 in this problem. So we'd write 16 divided by 2. Okay, so this would be 16 divided by 2 is 8. All right, exciting stuff. Okay, let's go ahead and move on to the next problem. So now we are going to go back to exponents. We're asked to write the expressions in exponential form. So for the first one, we have 12 squared. So I'm actually going to let you pause the video here and attempt these 3 problems, and then we will come back and discuss our answer. Okay? All right, hopefully you got a good crack at those and you have some responses that we can compare. So for the first one, we have 12 squared, and we're asked to write this in exponential form. So we want to go from the words to the mathematical statement. So here we have 12, so I'm going to say 12 is my base, and squared is going to be my exponent. So what is that going to look like? It's going to look like 12 squared. Okay, hopefully you got something like that. For the second one, we have z to the 6th power. So z is going to be my base, and 6th power is going to be my exponent. So z to the 6th. Another math tip that I would like to throw in just fairly quickly. I have a lot of math tips, but for now, whenever we write a variable, we usually have, we want to make sure that it is clear, that it is distinct in its own way, and z is a perfect example of that. Z can look like a 2, so we want to write that line in between so that we know that this is a z and not a 2. Just another thing. Usually also S's are a problem because they can kind of look like 5s sometimes. And so just for Z's, we want to make sure that we really are talking about a Z, because this can lead to confusion. So like, remember, we talked X's are no longer for multiplication. When we write our variables, we want to be clear that we're talking about the letter representing a number and not a number itself. Okay. Just a quick math tip. We always appreciate those around here. Okay. So let's go ahead to the last one. We have 2b times 2b times 2b, and we're asked to write this in exponential form. So my base is going to be 2b, and my exponent is going to be the number of times that I've written out this 2b as a factor. So that will be 3. So I write 2b raised to the 3rd power. Okay, so hopefully you got something similar to that. And let's continue. If you have any questions, please go ahead and let me know. I'll be happy to answer any and all concerns. And for now, we're going to move on. So we're going to evaluate the expression for the given value of the variable for 9t squared when t is equal to 3. So t is equal to 3, and so I'm going to replace t with 3 and square that. Now I can write out the factors, 3 times 3, and this will give us 9 times 9, which is 81. You could do it like this, but like I said, if you already committed these things to memory, you're a math superstar. So we have 9 times 9, and this would give us 81. Okay? Alrighty, same thing, same process, but just do this for clarity. So for the next example, we have 7h, all of this raised to the cubed power, and we're asked to evaluate when h is equal to 1. So I'm going to replace h with 1, and this will give us 7 times 1 raised to the cubed power. So I'm going to do this multiplication on the inside and then do this. 7 times 7 times 7 is going to give us 343. Or actually, let's show that. Let's show what we did. So we would have 7 times 7 times 7. 7 times 7 is 49. 49 times 7 would be 343. You could always use a calculator for this as well, or you can just, off to the side do this, okay? Whatever you feel more comfortable with. Okay, let's go ahead and continue. And that is the end of our practice set for exponents with a little bit of mixed review of algebra and variables. Today we discussed how to write expressions into exponential form. We evaluated variable expressions with powers. We evaluated powers on their own. We also did a volume problem. And also we reviewed our definitions of variables and how to use substitution in order to simplify. and find the result. So we did a lot today. Next time, we will begin our discussion on order of operations, so a completely new section. Thank you so much for your time and attention today. I really do appreciate it. And next time we will continue, and I hope that you can join me. But for today, that is all. And thank you so much for watching, and I hope you enjoy the rest of your day.